Okay, welcome everybody to the third day to this session, and we are starting now with David Baraclough and Anastasia Samsonova. Welcome to everybody, and we can start now.
Okay, thank you very much. I'll share my screen to show the presentation.
Okay.
Yeah, could I just ask attendees, please close your mic if you have it open. I was hearing a bit of background noise. Okay, so I'll try to share my screen. Oops. I'm trying to go back. Okay. Can someone please confirm they can see my first screen?
Yes, I confirm. We can see your screen.
Okay, thank you. Thank you everyone for joining this training presentation today. So the session is on, it's called Best Practices for DSD Creators. My co-presenter for today will be Anastasia Samsonova. So please, Anastasia, would you like to present yourself?
Yeah, good morning, good afternoon, or good evening, everyone. It's a great honor to present today with you, David, and to all of you. I'm working in David's team, and we are currently doing a big remodeling exercise of existing OECD data to Sdmx and migrating it to Dsd suite platform. So today we will try to share with you the rules that we try to follow in our exercise. To you, David.
Yeah, thanks, Anastasia. I guess I should introduce myself as well. I forgot to do that. So yeah, I'm heading up this this project at the OECD to restructure all of our data and metadata that we have at the OECD, so that we're following the Stmx data modeling guidelines to do it. Mainly so we can put it into the syscc.stat suite platform, which is a kind of a Stmx native platform. But we're following the general Stmx modeling guidelines to do this. It's not so much the constraints of the system, it's really the modeling guidelines that we're using, which actually came from the Stmx Statistical Working Group. So I'm also a chair of the Stmx Statistical Working Group, which formulates a lot of these guidelines and the cross-domain code lists, and we'll be seeing some of these today. In fact, the modeling guidelines is the main thing that this presentation is based on. So yeah, the purpose of the presentation is really to give you some guidance on a step-by-step approach on how to design Stmx data structure definitions and the related artifacts. So, I mean, wouldn't it be nice if we had a method that we can follow in order to do this seemingly very complex task? We get a lot of questions from it, both from inside the OECD, but also from our member countries as well and outside. So yeah, this has already been formulated in the modeling guidelines and built upon as well. There's things that that we've since found out that should probably go into a new version of the modeling guidelines, especially now that there's Stmx 3 as well. But if we're going to do it, the vast majority of it could be applied to Stmx 2.1 anyway. So yeah, as I said, the main guidelines or documents that this training is based on is the modeling statistical domains in Stmx. Okay, the link is in the presentation. And this is actually part of a kind of a greater guideline, which is called the Checklist for Stmx Design Projects. So the checklist actually shows how to manage a project for designing Stmx structural metadata, because there's project management things as well that you need to do around the modeling statistical domains. Typically a structural modeling project may encompass a single or multiple statistical domains or a subdomain. And something like the Sustainable Development Goals, this is very much a multi-statistical domain project. And also short-term economic statistics at the OESD, this is a multiple statistical domain. But then you have like, labor statistics or national accounts, and this is obviously a single domain. But the same step-by-step approach applies in whichever kind of project. And also we just include some differences on reporting and dissemination that you should consider when actually building this model in the step-by-step approach. Okay, so this is the step-by-step guide in a kind of zoomed out high-level view on the steps. It looks very much like a water flow approach, but there's definitely some iteration going on between these steps. So first of all, we describe our exchange needs in the project, and we'll be looking at how to do that and drilling down on it. And then identifying the statistical concepts for those exchange needs. When we have the list of concepts, we'll decide on the roles for them. We'll define what is called a Dsd matrix, which is very important. I'm not going to it now, but we'll see exactly what that is later on. And especially Anastasia, this will be part of a demo that she'll be showing. Then we will optimize the model that we've built. And this is definitely where we'll have some iteration around, steps 5 to 2. Then after that, we will fully define the code lists. And finally, we'll build the Stmx bits and pieces. So, okay, next slide. So on the exchange needs. So here, what you're doing is basically building a data flow diagram where you will show what agencies are involved in the statistical exchange. You add lines between the nodes in the data flow diagram, so that the lines between the agencies describing what those data exchanges are. You'll say what the direction of data flow it is, so who is sending this kind of packet of data to who. And finally, you'll decide what is in and out of scope of the project. Because after you've, say for labor statistics, what we did in the working group was we kind of listed all of the exchanges which happened in labor statistics. And then we decided that actually some were out of scope of the project for whatever reasons. Yeah. And the end result, the diagram defines the overall scope of the project, and it can actually be taken, the lines of in the diagram can actually be taken as data flows kind of later on in the process. It's very important. It almost directly implies. And also, yeah, the nodes on the diagram, they can be translated to agencies in an agency scheme. Okay, so in compiling this diagram, this is a typical kind of first step in the diagram. So you say, and again, this is for labor statistics. And the first thing that we did was simply to list all of the agencies that were where we wanted to describe the labor statistic exchanges. Okay, so and we depicted them in this way. So international organizations or simply collectors of data were in blue. The reporters were in this kind of lozenge orange. And also you could say, well, maybe we want to consider a anonymous user as well, like a dissemination channel, which we could add here as a kind of green dot. So this is all you're doing. You're just listing all of the agencies which are potentially in this project, but you're not losing sleep as to whether they'll definitely be in the project, after all considerations. So then the next step of this is where you define the actual exchanges. So here we can say that from the BIS to the ECB, well, there's an exchange of negotiated wages data, okay, from the BIS to ECB. We can see that Eurostat sent job vacancy data to the ECB. Also, from the central banks, they send national labor data to the statistical officers, etc., etc. Okay, and maybe also, the ILO, they publish statistical tables to the public on this dissemination channel. So you try to be exhaustive, and you describe all of the exchanges which are potentially in this project. And to create this diagram, I just used a free tool called Draw.io on the web. You don't have to use any kind of special costly tool to do this. And then the next step is to decide what is in and out of scope. So what we did was just the things which were out of scope after a lot of discussion, we just colored them in red. So we said, okay, the negotiated wages, exchange between BIS and ECB, and also national labor data from central banks to NSOs and to the BIS, and also the dissemination flow from the ILO. These weren't in the scope of the project. Good reasons for that, which I won't go into here, but you just do this for any project. You decide what is in and out of scope. And sorry, just to go back. And then this is your final data flow diagram. So which exchanges you have to cover, which data flows you have to cover, and kind of what you have to code for, okay, and the things that you don't have to code for, the things you don't have to model for. So this is a view on a data flow diagram for a different kind of project, which is more around dissemination. So here you may have a dissemination platform. There is a reporting data flow going to the UNSD, but there's also some visualizations to anonymous users, okay, to maybe the general public. So these have to be in scope of the project, and there's also excuse me. There's also a like a query orientated data flow, which is an application which is simply consuming an Stmx web service. Okay, so it's not built around visualizations. It's not built around reporting. It's simply, exposing the data for machine-to-machine communication through a web service. Okay, so, and this could be seen as like an alternative to the previous diagram, just a generic alternative to the previous diagram, where the project is taking into account reporting data flows and visualizations and this web service. And then you take this into consideration when you're building your structural model. Okay, so I just have to move this box. Okay. So then you come to identifying your statistical concepts. So, so a very important point before you start to do this is to, you should forget about your code lists and how many DSDs you need for now. Okay, so that this is built on experience where, you know, I've been in projects where we were saying, you know, how many DSDs do we need right at the start? How many kind of different types of packets of data? Well, no, you don't think about that like for now, because it could severely bog down the way that you actually structure the data, and you probably just have to come back to it anyway. And similarly with code lists, you don't have to start enumerating what goes into each variable now, into each concept. You can leave that detail until later. I mean, you may know if you have like an industrial activity list that this is probably going to be you know, modeled on the ISIC list, but you know, you don't have to go into detail exactly what that code list is going to look like. Excuse me. So the main part of this is to you find the logical list of concepts by decomposing a list of indicators that you may have. Okay, so and for labor statistics, this is what we did. So for all of the data exchanges which were described in the data flow diagram, we put them into a long list. Okay, and these were coming from the ILO, from Eurostat, OECD, etc., ECB, and put them into a long list. And then in a table, we found the kind of how to say, the individual characteristics in each indicator. And we put those in a table at the side of the original indicator. So we'll see an example of this. So this is really at the start going for a kind of pure approach, a kind of a normalized approach, because you're trying to build up a set of concepts that you can use to create your concept scheme. Okay, so some coined concepts we may wish to keep, because if they're already in use a lot, then we have to consider what the cost is of like actually changing from those coined concepts, because it's something that everybody just kind of uses all of the time, and it may not be worth changing it. But this has to be balanced against the advantage of, well, maybe by decomposing it and splitting it into different characteristics, we'll actually gain on being able to filter the data, you know, having a better search, having better queries, things like that, rather than keeping this kind of long indicator, which actually has several characteristics in it. So there's always this like purity versus simplicity approach, which and Abdullah, you know, described this on the first day. There's also some concepts which are not completely based on statistics, such as which are maybe needed for processing or publishing the data. I'll show some examples, so I'll just have some water because my voice is cracking up. So, and these are typically included in many Dsds. So things like unit of measure, although you can say this is based on statistics, unit multiplier, which is applied to a unit of measure, frequency of observation, something called custom breakdown, which is used to for reporters to be able to report new breakdowns which couldn't be originally coded in the DSD. They can't be foreseen. I'm not going to go into the details of it, but you know, these can be provided. Things on confidentiality and embargo, when data has to be marked up like this, and these also exist as separate guidelines. You can see some others here. I mean, observation status, so is a very, very important one. It exists in almost every DSD. Yeah, okay. So this is where we talk about, you know, how to identify these statistical concepts, how to decompose. So you typically have a table like this where you list the original indicators in rows, okay, and in labor we had working age population, labor force participation, but we had well over 100. Okay, this is just a very small set. And then so we say, well, okay, these are all obviously different. How can we try to like harmonize these concepts into a structure which would enable us to, you know, filter on data, things like that, you know, break it down in a harmonized way. Okay, so this is animated. I didn't know it was animated. So so working age population into the measure. We kept working age population. It was seen as a coined term. So yeah, so we kept it there. The unit of measure was persons. The age is working age. Okay. So let me just go in the whole table. Okay. So let's say we started at the first indicator and we say, okay, let's try to find the concepts which are needed to you know, describe this indicator. So we know that we will have a unit of measure, but also we want like an age breakdown, because we know that we have like several indicators which require age. So in the age breakdown, we can have working age. So with these three concepts, typically we can describe this indicator. Okay. For population, yeah, a very simple indicator. So again, into the measure. I mean, basically, the measure is what we use to kind of replace the indicator. I mean, basically, it's the thing being measured. Okay, it's the thing being measured, and the unit of measure is the unit. So yeah, maybe there's a better way of describing that, but that's kind of what it is. And then for population in age, we actually use this underscore T to say that it's a total. So underscore, where all the codes in Stmx which start with underscore, they're kind of generic reserved codes that have like cross-domain meanings and cross-code list meanings. So underscore T is reserved for total in any code list in any domain. Underscore O is reserved for other. Okay, and there's several of these codes. You can find them in the Stmx guidelines for coding. Okay, so we'll move to the next one. So for labor force, the labor force indicator, again, it's a bit of a coined term, so we'll use the measure labor force. The unit of measure is again persons. The age is again working age, because it's the labor force. But here we get to a new concept called labor force status. And in there, we can say that this is also the labor force. Now, it looks as though this may be redundant because the measure is already labor force, which it is in a way, but we have many other indicators which use labor force status as well, which have other things than labor force in them, you know, for the unemployed and things. So, so we should all the indicators that we have that are related to labor force status should be filled in. And then labor force participation rate. Well, this can be described as population, and it's a percentage of the population, the unit of measure. The age is working age because it's labor force, and the labor force status is labor force. Okay. Now, something that we've discussed quite a bit and made a decision on, at least at the OECD, is that in unit of measure, we should never just use percentage on its own, because it always prompts the question, well, it's a percentage of what? Okay. So even if it's there's some redundancy and repetition, you should say it's the percentage of whatever it is. Okay, so this is a recommendation that hopefully will make it into the next version of the modeling guidelines. There are many other concepts as well in the global labor DSD, but just here's some of them, because in going through the list of indicators, you can have things like work time arrangement, worker status, seasonal adjustment, and transformation. But basically, as you work through the indicators in this decomposition exercise, you'll build up a list of concepts in the columns. Okay, this is how it goes, and I think that Anastasia will show you, you know, how this works in something like the Stmx matrix generator. Because once you've done this, then you'll have two main things. You'll have the concept scheme, because you'll have all the list of concepts that you need, and you'll have a pretty good idea of how to constrain the data flows when we come to building the Dsd matrix. Okay, so when we include a working age population, we'll know that it needs to be constrained to working age in the age concept. Okay.
David, before you move on, we have a question from the Q&A. Maybe you could elaborate on it. It's not clear how annotations are used in that context. It's like some metadata that accompanies the data, and maybe you have some examples. I think that relates to the previous slide where you mentioned that some of the things used for dissemination flows could be covered by annotations. Maybe you could quickly elaborate on that to answer the question from Vilas from the chat.
Okay, yeah, this is a really great question. Thanks a lot for it. So annotations in Stmx, they're basically something on an artifact that you can put like any information. Okay, it's like almost like a tag kind of thing that you can put any information. Now, we saw in the working groups that they were getting more and more useful because there were several needs identified, especially how to visualize some Stmx artifacts. So, for example, in a data flow, so if you in a visualization tool, if you wanted to show a data flow, how should a concept actually be presented? Should it be on the x-axis or the y-axis, or should it be hidden? Things like this. Now, there's no way in the Stmx information model you can do that, because there's no kind of attributes to do with presentation. So, but we really wanted to do it. So this is why we now have a controlled vocabulary for annotations. Okay, and this is published on stmx.org, where you can see this list of annotations, which can now be built in as part of your model. And even the matrix generator has a column for adding annotations. Okay, so it's kind of extra, it's mainly presentation or processing metadata that you can add to artifacts. Okay, so I hope that this answers the question. There's quite a lot more on it that we haven't really got time for, but please, I'd say Google for Stmx annotations control vocabulary, and you'll come to this document, and it describes everything in more detail. Okay, so I'll move on in the interest of time. So here's some more decomposition. So I'll just go back. So yeah, on COVID data, this is how it can be decomposed. So say an original indicator of daily COVID-19 new cases. Okay, so we can say the measure is COVID-19 new cases. The unit of measure is cases. Indicator reference period is today. Okay, indicator reference period is a cross-domain concept. Okay, and you can find this in the Stmx glossary, which I really recommend that you use in your modeling when you're modeling and you want to harmonize data, especially with in the whole Stmx community. And then we can use a concept called aggregation operation, which says what type of aggregation to apply to it, or what this is, and it's simply a count. Okay, and then the next one, weekly average COVID-19 new cases per 100,000 inhabitants. So we can see it's a very long indicator, but it can be almost simplified by saying, well, again, it's the same measure. Okay, it's the same thing which is being measured. But the unit of measure this time is cases per 100,000 inhabitants. The indicator reference period is a week, and the aggregation operation is a weekly average. Okay, so you can see here that we've gained some alignment in a statistical table on the measure, and also searching. If we search for COVID-19 new cases or filtered, then we'd find two related things. At least I haven't looked at the others yet. Whereas searching, filtering, you wouldn't be able to find this. So then the next one, this is patients in ICU, different unit of measures, persons, indicator reference period is today. And the aggregation operation is just an account this time, it's just a number. Daily number of deceased because of COVID-19. Just simplify the indicator into the measure. We're counting persons. I don't know why this is week, but maybe it's a mistake in the slide, but maybe it should be daily, and it's a count. And last one, total number of deceased because of COVID-19. So it's deceased due to COVID-19. So we have an alignment on the measure, talking about persons. From the beginning of the pandemic, it's the indicator reference period. And again, it's just a count. Okay, so hopefully you can see how we can decompose the information in the indicators to something which can be much more easily filtered and sliced in a hypercube. Okay. So deciding on the roles of the concepts. is the next phase, because sorry, just to back up. So here, after we've completely decomposed everything that we have, in the columns we have our the list of concepts that go into our concept scheme. But then we have to decide on the roles of those concepts. So the breakdown concepts are dimensions. Okay, so breakdown concepts or the parts of the series key, you know, that are used to identify the data. If you remember what Abdullah said from the first presentation, these are dimensions. Okay, the information for processing the data, yeah, okay, so just on this, for processing the data, they're attributes or annotations. Okay, so say you know, processing the data, if we're talking about presentations, especially what goes onto an X or Y axis in a visualization, this is an annotation. Okay, but something like observation status or reason for a break, something like that, this would go into an attribute. I mean, it's needed to kind of understand the data, but it's not needed to identify the data and to uniqueify the data. So yeah, information necessary for understanding the data, like observation status, they're attributes. So say if a value is estimated or not, this is definitely an attribute, this observation status, or if it's confidential, it's confidentiality status. And then for information just for the human understanding of data, this is reference metadata. Now, I think that this was a question that was raised in the first presentation by Abdullah, but we ran out of time right at the end. This is perhaps the chief difference between attributes and reference metadata, is that reference metadata is really for human understanding of data, and it can be sent separately from the data as well. Okay, so now, oops, let's go back. So it says in an MSD, in a metadata structure definition, that's a bit difficult in 2.1. Well, we've certainly, you know, found it difficult. So sometimes reference metadata has been exchanged as a DSD, either by adding to an existing DSD with data, or just having a separate DSD completely and sent as attributes. But in Sdmx 3, hopefully we'll start using MSDs much more. And then deciding some aspects of the attributes. So again, Abdullah went into this quite a bit, but I won't here. Attributes need an attachment level, which is either typically a data set for the whole message, at the series level, or an observation, or at a kind of custom group level, which is a partial key. Okay, and as Abdullah said, it can always be attached at the observation level, but then you'll be losing, you'll be using a lot of space in your data messages if you do that. You need to decide whether a value, an attribute value, is mandatory or conditional, whether it has to be sent with the data message or whether it's optional, conditional. And what the attribute data type is. So, well, I mean, it can already be, it can be a code list, it can be coded, but if it's not coded, then it needs a type. So it needs to be either string, integer, date, time, or there's a long list of types that they could be. Okay, so that's it for the roles of the concepts. So we're coming to the demo, but let's just go through the optimization. So now you have the concept scheme, you have the data flow descriptions on your data flow diagram at the start. And you have the decomposition table where we said, where you have the original list of indicators, and then you've decomposed those into the concepts for your concept scheme. So what we can do is we can go through this optimization list to come up with a better structure. So, so on the decomposition list, we should remove concepts that are used in only one original indicator. Okay, so if we just back up a little bit, so say in this table, if indicator reference period, after we've gone through the whole decomposition exercise, if it was only used for one indicator, then really we should remove it, and we should include the data, the information here into the measure. Okay, because it's useless having a concept just for one indicator. And then, well, similarly, we should keep concepts that are used in all original indicators, because through the decomposition we could see that these identified concepts, they're well used. And then the information which is in this kind of new concept, we can remove that information from the measure concept. So what this means is, say when we decompose this, if we put daily into the measure, okay, and indicator ref period says daily or today, then it means, well, we've got this information into this extra concept, so we can remove daily or today from the measure, which is what we did anyway. Okay, so so it's where we can, we should remove this kind of redundancy, although sometimes the redundancy helps. Okay. So and then more analysis is required for concepts that kind of between when they're only used in one indicator and when they're used in all of them. So if it's very few indicators, then it's a judgment call. Should you keep the concept or not? You should consider kind of removing it and keeping the information in the measure. If they're used in most indicators, then you'll probably keep it as a separate concept and remove the information from the measure. And then, finally, we should keep concepts that reuse existing code lists. So industrial activity, the national accounts institutional sector. If there's a clear usage of existing code lists, then it's a good idea to just keep the concept in. So yeah, that's a lot of information. So I think I'll just pause for any questions. At the moment, we've already had some, but does anybody want to raise some specific questions? I can't see any, so I'll carry on. So the next thing is to define a Dsd matrix. So what is a Dsd matrix? So it shows basically which concepts are used on which data flows. Okay, so if you go back to the data flow diagram, each of those lines that those exchange needs on the diagram, the label on the diagram can be put in a row in a table, like a data flow. So job vacancy was one of those data flows. And then we can say, well, for job vacancy, and sorry, we put the concepts, all of the concepts that we've identified, we put them into columns in the table. Okay, and we'll see again, you know, Anastasia will show this. And then for the job vacancy data flow, we say, well, which concepts are used on that data flow? All right. And if you know the data flow, then this may actually be quite easy. So job vacancy, by the way, I just kind of made this up, so don't think that job vacancy is always like working age and population. I just like, you know, put those labels there. But we say, okay, for job vacancy, it's not broken down by sex. Okay, just pretend that it's not. But it is broken down by age, or well, it's identified as always being the working age. Okay, so we can say we put working age under age. Okay, and we say well, the measure is population. Okay, so just to say, please don't think that job vacancy is always population. I'm just saying that, you know, for this example, we're saying that the measure is, for this data flow, is population. Okay. The adjustment concept, it doesn't apply to this data flow. It was in the it was in our concept scheme, but it just doesn't apply to this data flow. So we'll leave it blank. For unit of measure, there are several unit of measures which apply to job vacancy. So it's not single fixed. There are several, and we use the percentage sign to denote that there are several units of measures possible. And this is important when we come to defining constraints. And labor force status, again, there are several types of labor force status that can apply to job vacancy. And then you come to the next data flow, and you go through the same exercise. So earnings, so this is broken down by sex. It's not broken down by age. Yeah, I should say, why is there a hash sign under sex? So it means that it's broken down by sex, and it can be any sex. Okay, so it's not constrained. It's like anything in the sex code list can apply to the earnings data flow. Age doesn't apply. Again, just pretend that it doesn't apply. Measure, again, it's broken down by measure, but it's completely unconstrained. Adjustments the same. It applies, but it's unconstrained. Unit of measure can have any unit of measure, and it can have any labor force status. And then for the next one, labor cost, well, hopefully you've understood now, it's not broken down by age, but it is by sex, any sex, any measure. Adjustment, there are only certain adjustments that apply, and it's broken down by adjustment. Same for unit of measure, but not at all for labor force status. And you can see that the little legend here hopefully explains that. And this is part of the matrix generator as well. And then we can have, so once we've done this and defined the data, the Dsd matrix, like a first pass, then we can go through another optimization exercise, about another iteration, where we may want to remove any concepts that are rarely used in the data flows. Okay, so if we see that in the whole Dsd matrix, there's a concept that's only used for one data flow, then after analysis, we may say, well, we just don't need that concept. So we may want to remove it from the concept scheme and fold that information back into the measure. Okay, but this is like an analysis step, a judgment call, just something to consider. So I'm just where yeah. So how are we doing for 10:16:52? So okay, so the next thing is to once we have our matrix, we should fully define the code lists. Now, a concept can be coded with a code list, or it can be uncoded. Okay, and if there's no code list, the concept must have a data type. You find this in the concept scheme. And for coded concepts, it's recommended to reuse the cross-domain code lists. Okay, so you should check Sdmx.org for that. And it's also recommended to define the code list in the concept scheme and not just in the DSD. Okay, I mean, the matrix generator does this anyway, but when you define it in the concept scheme, it means that you can reuse that code list easily across several DSDs. And then there's some things to check for existing concepts and code lists, like the global registry, rather than just always creating your own. Check the global registry, other registries, the cross-domain code lists. Okay, and the link is in the presentation, but you can just Google for it. And the Stmx glossary contains all of the cross-domain concepts. Okay, and it says whether there's a cross-domain code list for those concepts. But it's really important, I think, in order to harmonize metadata and to look at the things that have already been analyzed as best practices, to check the Stmx glossary for something before you create a new code for it. Use the guidelines for the creation and management of Stmx code list, because it contains strong recommendations on how to code items. When you create a code list, then always do it with an eye for reuse in other DSDs. So, and then the final step is to create the Stmx artifacts. So, assuming that you've gone through all these steps, you've gone through the optimization, you've iterated, over from those optimizations back to the modeling and removed and kept concepts, then you can create the Stmx artifacts. You have to decide, it's right at the end really that you decide how many DSDs you need, because this is done based on how the data flows kind of group together. Okay, there's an exercise, is it on here? Yeah, where if you want to kind of cut down on the amount of DSDs that you have at the end, then after going through the step on creating a DSD matrix, say if you have many flows and they're all different, then you may want to kind of group them together by filling in some of the blanks, by single fixing values, so that because all the differences in dimensionality in the DSD matrix will mean a separate DSD. That you can actually reduce the number of DSDs by filling the blanks. Okay, but it has to be done, by how to say, not just filling it with anything, but usually with usually with single fixing an unused concept to like total, something like that, or something that just makes sense. Okay. So the following artifacts are created from the matrix, but from the matrix generator anyway. So it creates a concept scheme with the concepts and their default representation, a DSD per dimensionality, and that's described in the matrix generator, and a data flow per exchange need from the diagram. Okay, so these automatically translate to data flows, and a content constraint for each data flow that really defines what is actually valid on the data flow. So if you say that for a data flow it's only annual data is valid, and then somebody sends quarterly data, then as long as the tool actually validates the constraints, then it'll flag up that this is invalid. Okay. And then other things can be created, like provision agreements and structure sets for mappings to other structures. But I guess this is part of the presentation. And this is a kind of generic graphic on what a DSD matrix looks like. So, but we'll see this again, in the matrix generator tool. So, in the rows are the data flows. Okay. The concepts and the code lists are in the columns. The whole thing, the whole set of concepts makes up the concept scheme, and we can see that each grouping of use of concepts are the data structure definitions. Okay. So we'll go to the demo of the matrix generator, but what time of it? So we're at the top of the hour, so maybe if we just have a very short break for just a few minutes, maybe 5 minutes.
David, before we break, can you confirm?
Yeah.
There was a Q&A. Can the slides be distributed to anybody? So I assume the slides are public, but can you just briefly confirm? There was a question on that.
Yes. Yeah, thanks, Daniel. Yeah, so the slides will be distributed. The slides for all of the training will be distributed through the conference website. I don't know exactly when, by the way, but yeah, they will be available. Okay, so if we have a short break for and come back at in 5 minutes. Okay, so. And then we'll come back to the matrix generator demo. Thanks a lot. Okay, so we should be back now. It's 5 past. So I should something I also forgot to do is to actually introduce our support person today, Daniel Sarani, who he works at the European Central Bank. But I think importantly, he managed the actual global DSD for national accounts, and actually it was in that project that a lot of this method for building the structures, step by step, actually came from, because it was seen to be a success, and we kind of made a set of general principles out of it, which became the modeling guidelines. So hats off to Daniel. Because a lot of this is actually based on his work in compiling the national accounts Stmx structures. Okay, so then if I hand over to Anastasia, who run the demo of the SISCC Sdmx matrix generator tool. So Anastasia, can you share your screen, or do I have to do something to give you those rights?
Yeah, I think you need to exit the screen sharing, then I can share my screen.
Okay, so where do I can pause share, stop share. Okay.
Okay, can you see it okay?
I can see it, yeah, on the pre-fill worksheet.
Yeah, exactly. So matrix generator is a tool that is being developed in OECD, actually by David. So we are using it a lot for our modeling exercises because it's quite powerful. It allows several scenarios. You can start from scratch and do the analysis of the whole statistical domain or partially of the statistical domain and generate the structures. Or you can work with the existing Sdmx structures, pre-fill the matrix generator with those, and do the necessary changes and regenerate the structures. So the sheet that I'm currently showing, it's an optional step. Just to say that matrix generator is a tool that is based on Excel features. So this is an Excel workbook that you can download from the, if you go to sdmx.org tools section, you will find a link to the matrix generator and other Sdmx tools. So you can download this Excel workbook and start filling it with your statistical artifacts to generate the structures. So the first step is optional. You can use it when you already have some Sdmx structures that you would like to work with. Then you can pre-fill from a file or from a REST API URL, and then manage your structures inside the Sdmx matrix generator. The matrix generator that I will be using is pre-filled with the global DSD for labor structures and also some indicators. So yeah, we have used the pre-fill feature here, but actually you can start from scratch and skip the pre-fill step here in the matrix generator and move directly to Decompose Indicators sheet. So on this second sheet with the Decompose Indicators, this is exactly what David was showing, where you first list all your existing indicators and source where they are coming from, and then you start to decompose those indicators. Like if we look closely, we can see exactly the same indicators that David showed in his slides. We have the labor force participation rates, employment, and so on. And one by one, we are looking at those indicators and try to decompose and think of different concepts that might be needed to describe those indicators. So here in this sheet, we have a lot of different indicators, almost 200. So the analysis of all these indicators has been done, and possible concepts have been identified and put here into columns. And then for each indicator, you try to decompose it. You leave empty those concepts where these don't make any sense. You can identify that a single value could be used for each of the indicators, or any value or several values. So the matrix legend that you can see here on the top, it will be used in several steps in the generation of the artifacts and the analysis of indicators. So you can already, starting from here, start using the hash to say that any value can be used for this concept, or percentage when several values can be used, or leave it blank if it's not used, or fix it to a single value when you know that it could be a single value. So this is where you do the first analysis of your indicators, and once done, there is a button on the top right corner to update the concept scheme. When you press this button, it will take you directly to the next step to define your concepts in a concept scheme. And all those concepts that were identified on this sheet, I mean, all these here, these will be automatically transmitted to the next step, to the concept scheme. So on the concept scheme sheet, by default, you would only have the IDs of the concepts that you have identified. And this is where, again, you start thinking, would it be a dimension? This is marked with letter D, or attributes, or measure. And for attributes, of course, you can also define if it's optional or mandatory, and the attachment level where it could be attached. For each of the concepts, you can define the name and the description. By default, we only have English language here, but you can add more columns to support some other languages and have the translations in other languages. And here in column C, you fill the you define whether the concept is coded or uncoded. Again, here.
Anastasia?
Yeah.
Anastasia, it's David. Could you just slightly increase the font size, please? So somebody is asking.
Yeah. Is it better?
I think so. Yeah. Hopefully that's fine for everybody. If we increase it too much, then we'll lose too much information on the page.
Yeah, we don't see all the columns if we increase it, but hopefully it's fine like this. Yeah, this matrix generator is not an easy one. It has a lot of information inside of it. So yeah, we will see it also in the next steps, how complex it is actually. Yeah, I was talking about defining if it's concepts are coded or not. At this step, you can just define if it's coded. If it's coded, then you say you put here CL underscore and ID of the code list. And if it's uncoded, you just say it's uncoded, and you can say what type it is. And if it's, for example, string, you can add some additional requirements. Like if it's string, it should be 1 to 25 characters. But yeah, here we are not filling the code lists yet. This column is needed to automatically generate the sheets for each of the code lists that you identify, and then in the next steps you can also fill the code lists. So once
can you explain the position column? There was a question on that.
Yeah, this position column, I think it was introduced recently to keep the order of dimensions in a DSD, like explicitly say that this dimension is on position 1 in the DSD. But I think it's optional, and it's more needed when you pre-fill from the existing DSD in order not to lose the existing order. You can use this position column because this is.
If I may, it was put there to ensure the order of concepts for in the REST queries. Now it's actually going to change in the next version of the matrix generator, because what actually the only thing that counts in the order of the concepts actually is the position of that they appear in the XML, okay, in the XML structure, and this position information in the actual Stmx information model is purely like an information thing. It sounds a bit weird, but so what will happen in the next version is that when the Stmx is generated from the matrix generator, it will generate the XML, the concepts XML in the order of position. Okay, Now, position is completely optional, and if you don't want to use it, then simply don't fill it in. Okay, but the idea is that if you put a position for something, you should put a position for everything. Okay, well, all of the dimensions anyway. The time dimension will always come at the end, but that's how position works, and how. But basically, it's going to change in the next one, so that really the position will affect how the order in which the XML is generated. That's it.
Yeah, and
Thank you, David.
this is Abdullah, and if I may just very quickly add, the position of dimensions is very important because it defines the structure of not the structure, but the composition of the REST query. So when you may or may not choose to use the position field, but in either case, you need to make sure that you don't switch the dimension around, because that will disrupt REST queries to your data flow. Back to you, Anastasia. Thank you.
Thank you, David. Thank you, Abdullah. I think we can go to the next step. So once everything is filled here, we have another button here on the top. Update Dsd Matrix, code list from concept scheme, and go to Dsd Matrix. Basically, what it does, it again takes all concepts from the columns that we defined here. It also generates the sheets for the code lists that we can fill in later steps. And yeah, when you press this button, you go to the next sheet. This is the matrix where you actually already start designing your DSDs and data flows. So there is a column to define DSD, column to define data flow ID, all the concepts that were defined in the previous steps. And next to each column, you need to define how these concepts will be used. And based on this decision, you will see if it all fits into one DSD, or you will need to have more DSDs when there is a difference in dimensionality. So this example is quite complex. It has 47 different data flows that in the end, I think fits into six DSDs. So here, yeah, data flow by data flow. At this point, we already know what exchange needs you have and what data flows you have drawn on your data flow diagrams. So here, for each data flow, column by column, you need to define how all these concepts that were identified as dimensions or attributes will be used in this data flow. Again, we have here the same legend. If it's hash, then it means that all codes in this code list for this dimension or attribute can be used. If it's percentage sign, then it means that code list can be used partially. If we have just one code here in the column, then it means that it will be single fixed. It can be single fixed into a code with some special meaning, or sometimes it's used to fix to not applicable when this dimension is not applicable, or to total to, let's say, switch off this dimension but still use the same DSD. And then for those concepts where you identify that it will be used partially, you will need to see the code list and define that for this data flow, only these codes are allowed. This means that when you upload the data, there will be check if this code is allowed, and when you extract the data, you would only get the data that conforms to the codes that you have identified. Like, for example, here, if we click on CL unit measure, this is the code list for units of measure. We have here some constraints for several data flows. For example, for the data flow GVSFL, it was identified that only codes vacancies can be used. And this means that when you try to submit data with any different code, it won't be accepted. Only codes defined here can be used. And again, in this code list sheet, for each of the code lists, you can define all the codes for this code list. You can define their names. You can additionally add new languages. There was a question about annotations. For example, one annotation that we are using quite a lot in the code list is the order annotation, which is hidden here under the column order. But with the help of this column, you can say that this code will be always the first one, and the second one will be the second one, and so on. But this will be just attached to this code, and it will be used for the dissemination, for the visualization, for example. It won't affect the Sdmx message itself. The Sdmx message, when you query for the structure, will just carry the information that's order, the desired order for this code is 1. It won't change anything inside the structure. But in some systems that can visualize the data, this order can be taken into account, and the code can be displayed in the order defined here. The same for data flows. So we have here the two more steps left for Dsds and data flows. Actually, these are done more or less in parallel. Because already in the previous step, you have defined what Dsds you will have and what data flows you have. And here on Dsds sheet and on data flow sheet, the first columns are similar. You define here ID, agency, and version, the identifier of the Dsd. You say whether it's true or whether it's final or non-final. And you can define name. Again, it's here in English, but you can do it in several languages. The same for on the data flows sheets. You start here again with the ID, agency, version, that the triplet identifier, if it's final or not. Then define the name, the description. But you can also specify some additional details here, like you can generate categorizations from this sheet. You can say that we are using this category scheme with this agency ID and version, and this is a category in the category scheme. And when you generate the artifacts, then the additional categorization will be generated. The constraint ID, I think it's generated by default when you fill details on the code list sheets. And other columns here are, again, for visualization purposes. Actually, annotations are hidden under these columns. And here you can define that for this data flow, please put these concepts into rows and these concepts into columns and this into row sections when you visualize the data. And please not display some of the codes in the table or use the default pre-selection in the visualizations and so on.
Yeah, Anastasia, is it almost the end of the demo? Because we just need to kind of move on, and if we're going to get to the Mentimeter quiz.
Yeah, perhaps the last step, when you have pre-filled everything, this is the step to generate the structures. You have this generate Sdmx sheet, and on this sheet you can say what artifact types you would like to generate. You can put one next to all of them, and it means that everything that was pre-filled here, your concept scheme, your code list, your DSDs, data flows, categorizations, and constraints will be generated, or you can choose just some of them to generate the artifacts. You can say here whether to output them to a folder or directly to a web service, or to both. You can say whether to create separate files or have everything in one file. Then you can just submit this full file to the web service and create structures all at once, or you can submit them separately. And yeah, perhaps that's it. This is the most useful feature here. When you do the analysis, the modeling of your structures, and then in the end you can generate the Sdmx.
Okay, thanks a lot, Anastasia. Yeah, as Anastasia described at the start of the demo, you can you can create the structures and put it into a data warehouse or a registry, and then you can also pre-fill. If you need to make a change, you can also pre-fill the matrix generator by going to the pre-fill sheet. Although to actually maintain artifacts, you may want to use another tool, such as the registry or the Dsd constructor, which is more on the kind of it's more focused on making changes to individual artifacts, and the maintenance phase. The matrix generator is really focused on the design, the step-by-step design process, following the modeling guidelines. Okay. So then if I share my screen, we go back to, can you stop sharing, Anastasia, please? Okay. So then if I share my screen, going to, yeah. So then just to whiz through the Stmx guidelines. Okay, so these are like bits and pieces that you can use in the modeling process. I already mentioned a lot of them, but just to show what they are. So yeah, you have this big diagram that you can't see because it's too small for you on the left-hand side. But looking at the statistical guidelines part of Stmx, we can see that there are several components of it, which we'll go through now. So first of all, there's the Stmx glossary. Okay, so this is a control vocabulary that where everything is coded, and they can be used in Stmx data structures and modeling. Okay, I mean some of the things you wouldn't generally used in modeling, but they're coded anyway. We just made a decision at the start to code everything in the glossary, and so this became the Stmx cross domain concept scheme. Okay, so please look at the glossary to check to see if you can use these concepts, because like this you can build harmonized data, which makes it much easier to exchange with other agencies and cuts down on the mapping, etc. There's about 250 cross-domain concepts in there. There are also the cross-domain code lists. Again, these are on the stmx.org guidelines page. There's about 20 of them available. And these are predefined code lists that you can use, like frequency codes, observation status, confidentiality. There are also things like industrial activity, sex, age code lists, etc. There are some things there are some parts of this which are used to actually build code lists, because it's very hard to come up with a single harmonized list like CL organization, because there's so many different types of I'd say government organizations in countries, but we try to create the kind of the building blocks you can use to create such lists. Statistical domains. So the UNECE created a classification of international statistical activities, which became the category scheme for Sdmx. And this is available in the Stmx global registry. So you can use this perhaps to classify your statistics for discoverability, or at least to be able to map it to it. And then there are many guidelines on things which aren't, they're not just cross-domain concepts or code lists, but they're how to do things in Stmx, basically, you know, statistically, not so much the technical aspects, which they're managed on by the technical working group. So such as the governance of commonly used artifacts, modeling statistical domains, which is exactly what we've been talking about in our presentation today. Guidelines for DSDs. So this is like an earlier document which talks a bit more about what Abdullah was talking about the first day, like the parsimony and the simplicity, etc., of modeling statistical variables and concepts. Guidelines for creation and management of code lists. So this is very good on how to build code lists and the best practices on what to avoid, and it has like syntactical notations in there that you can use. Versioning of artifacts, etc. So you can see the list there, but there are more. And then, as I mentioned in my first slide, there is this checklist for Stmx design projects. So yes, I know that it's very hard to see this text, but just to fit this whole thing on, it was kind of modeled on the GSBPM standard. We can see that the design, what we've been talking about today, the modeling part, is really this pillar here on the design. I don't know if you can see my pointer, but it's on the third pillar. Okay, and this takes you through the process, you know, more or less how I've been talking about today, and it has a reference to the modeling guidelines. And but you can see, you know, all the extra steps around the design project. On artifacts governance, so once the artifacts have been built, then there are extra aspects to consider, like who will actually maintain the artifacts, who is the actual decision-making body on changing the artifacts, and you know when to version it, things like that. You know, this has to be decided if the artifacts have a serious lifetime. The maintenance agency, which is part of an artifacts identifier, can be used for this, and an organization can use agency schemes and have some kind of permission system, you know, to determine who can edit what. I mean, this is part of, for instance, the .stat suite system. It uses that. Probably other systems. I know that the Fusion registry does as well. Now, on the artifacts maintenance, we've seen that the initial design can be done with the matrix generator, but several other tools can be used for the maintenance phase, such as the DSD constructor, Fusion registry, Stmx iStat toolkit, meta manager, and several others. Look on stmx.org tools. And if we've got time, just Anastasia, can you show that just a really brief demo of the DSD constructor?
David, before you move on, a question either to you or Anastasia. We have from the Q&A, which is, did you use the matrix generator together with the .stat suite? Is it compatible? The artifacts you create from the matrix, can you import them to the .stat suite?
Yes, definitely. In fact, that's exactly what we're doing. But really, it's compatible with it because there's no it's not tightly coupled to any system. Okay, you use it to model your Stmx, to model your statistical information, and it creates Stmx artifacts that then you could upload into any other system which accepts Stmx structural metadata. Okay, so we're using it for .stat suite because we're at the OSD and this is what we use. But you could also use it for the global registry or another kind of fusion registry, or presumably for the ISTAT toolkit, or or something else. So hopefully I've answered the question. Okay, so yeah, Anastasia, just really briefly, the DSD constructor, is it possible, or?
Yeah, if you can stop sharing your screen, I can share mine. Can you see it okay?
Yes, I can. Everything's a bit small, but I don't know if you can do anything about that.
Yeah, I'm not sure I can do
That's
anything.
better.
So this is another tool that supports Sdmx that is being developed by ILO, and it's called Dsd Constructor. You can also download it from sdmx.org and tool section. So what I will be showing is actually answering the previous question. The file that was generated by the matrix generator, I will be using for this demo. I can I prefill it from the file global to GAN multiple that was generated by the matrix generator. As it is Sdmx 2.1, it can be used in any tool that supports this. So when I prefill from this file, you can see that all these 6 Dsds that I had in the matrix generator have been loaded. If I go here into data flows section, you can see all the 47 data flows that were generated from the matrix generator. We also have here the code list section and the concept scheme section and category scheme and content constraints. So we can use this tool or any other tool to modify the existing structures. For example, here, if I would like to add a code to a code list, I can either go from a DSD and see all the dimensions and click on the dimension from the dimension list, or I can go from the code list and find a code list that I would like to modify. Like, for example, here, if I would like to change something in the CLH, I can click directly on it. And when I click, I can see a list of codes that are already there. I can add a new code by clicking on the plus sign here that says append, and I can add a new code test, for example, to this code list. Of course, I need to think about the versioning, how all these codes, new codes that I add or remove from the code list affects all the other artifacts that are using this. But in principle, yeah, with any other tool that can work with Sdmx, you can maintain the existing artifacts. And from here, when you generate, you can press export and save it, for example, to Sdmx.ml, and it will generate just this one code list, or you have an option to export everything that you have here.
Okay. Okay. thanks a lot, Anastasia. Is that the main thing that you wanted to show, or was there something, some of the key?
Yeah, that's it.
Okay, thanks a lot. Yeah, if you could just stop sharing your screen, please. Okay, so okay, so that was the demo of the DSD constructor. So now, well, we have some Mentimeter questions, but I'd like to ask Luca. I mean, because we're a bit over time, do we have time for the quiz? I mean, it's your call, Luca, because I think it's is it your presentation next?
I'm next. We can do the quiz. We can do the quiz. We'll fit within the time frame.
Oh, it's so nice to me. Thank you, Luca. So should I stop sharing and are you going to run the Mentimeter?
Yes, I have the quiz ready. So I'm going to share my screen and we can run the quiz. So you should now see on the screen the Mentimeter quiz, the first slide. It says question 1 of 1, but there are actually 3 questions, so you're going to have to work a bit harder. For those of you who have participated in the previous sessions of the capacity building of this training, you know what to do already to connect. For those of you who do not know, if you want to join the quiz, go to www.menti.com and use the code you see there when prompted to join the quiz, 54728721. Once again, take your phone, tablet, PC, laptop, whatever, go to www.menti.com and insert the code at the top of the screen and you'll be able to join the quiz. If you're not able to join immediately for whatever reason, don't worry. Even if you miss one question, you can join at any time during the quiz. So I will give you a few seconds to keep on joining, and then we'll start. Once again, go to www.menti.com and use the code above to take part in this quiz.
Yeah, and again, I feel quite guilty because it's yet another thing that I forgot to mention to anyone at the start of the presentation, that there was a quiz. So yeah.
It's a surprise quiz. That's when back in school, same thing. Okay, I think we can start. Let's go. So first question. What are the steps to follow when designing DSDs and related artifacts? You have 4 options, and for each option, you have a different sequence of steps. You need to choose the right one. There's only one right answer. You have about 2 minutes, a bit less than that now, to enter your response.
Yeah, the different steps are, well, if it's not obvious, but they're separated by the commas. I mean, I know that the text is a little bit jumbled, but hopefully you can see, you know, the different steps.
Okay. It looks like about 2/3 of you, 2/3 of those who joined the quiz participated. We still have about 10 to 15 people left. And once again, by the way, if you're just coming now or just able to connect now, you can connect. Just go to www.menti.com and enter the code above. All right, 10 seconds left. enter your answers now. If you're still pending, there we go. And let's see the results. What do you make of this, David? It was a tough question.
Okay. So, well, 9 people got the correct answer right. Now, I guess at least the correct answer was it's a little bit similar to the wrong answer that most people went for. Just the code lists were the code lists are kind of in the wrong place, because the optimization should really occur before the code lists. Now, I think I did say that there's some optimization again, at several stages after the code lists as well. So that may be partly my fault, but the main optimization phase occurs before the code lists are compiled.
Indeed, the main optimization is at concept level, usually at the level of the concepts in the DSD structure, so the code list.
Yeah.
But this was a tough question. I must say as well, when I first saw the quiz, I had to think about it a bit.
Yeah, but at least the people who got it wrong, it's like the next most right. Does that get me out of the hole?
All right, let's go to the next one. Here, the question is about a little exercise. You need to create a DSD for some tourism-related indicators, which you see here in this small table. These are 3 tourism-related indicators. What is a list of concepts that this set of indicators can be decomposed into? And I apologize for the typo in the question. So what is the list of concepts that this set of indicators can be decomposed into? You have 4 options. And once again, here the concepts are divided by a comma. And yeah, that's about it. Oh, I should hide the results for now. I don't know if you want to share anything else. We'll start the countdown when you tell me, David. It's a 60-second countdown.
Yeah, I guess. This is a bit of a tough one. I mean, what you got to do is you got to look at the first indicator and then think of what concepts are required for that, and then look at the second indicator and then kind of add to that set of concepts, and then look at the third indicator, and then add to the set of concepts. So it's like the superset of concepts that you need to describe these indicators. Okay, so yeah, you can start the countdown. So yeah, so just remember, you're looking at the superset of concepts that you need for these 3 indicators on the left-hand side. Yeah, I mean, usually you wouldn't have only 1 minute to do a decomposition exercise. So, but, let's see. Okay, 10 seconds. One.
There we go. Okay. Voting is closed. Let's see the results. And let's see the right answer. Okay. Once again, what do you make of this, David?
Yeah, I'm not surprised in a way, because the most popular answer, it had like this extra dimension in it, which didn't appear in here, but I just wondered if people were going to pick up on that. And with only a minute to actually do this exercise, it was difficult to pick it up. But the correct answer was kind of like the next set of people. But yeah, as I said, this is a bit of a tough question because you would normally need quite a bit of time to do this analysis, and all the indicators, they look a bit different, okay, even though the underlying concepts are very, very similar. Okay, so this, I mean, nationality is not in the indicators because, it doesn't say anything about the nationality of the tourists. It just says, all the visitors from or to places, broken down by visitor type, whether they're overnight or same day, the sex and the age, and where they're going, where they're coming from, or they're going to. But there's nothing at all about nationality here. That's it. Thanks.
Perfect. We can then move on to the last question. You need to optimize the design of the DSD. How should you do this? And once again, you have 4 options and 1 minute. So this is really about the optimization step that we dwelled upon a bit earlier in the first question. And what is the procedure to optimize the DSD? Oh, I should hide the results again. Sorry.
Yeah, there's only one correct answer. So.
All right, 5 seconds left. I see lots of people have not voted yet. Come on. Last chance. We had a rush at the end. There was a lot of indecision apparently. Okay, so voting is done. Let's show the results and let's show the correct answer. This one went a lot better, David.
Yeah, for once we actually got a majority of correct answers. Yeah, so you need to remove concepts in a few indicators and keep the ones that are used in many indicators. Yeah, you shouldn't really remove concepts that reuse existing code lists. This is something that you should keep. I mean, if the concepts are there and they're existing, they reuse existing code lists, and this means that you go towards having harmonized structural metadata. So it's a good idea to actually keep those concepts. Yeah, that's it. Thanks.
All right, I think that ends the quiz. I will stop sharing. And any final words, David? Or
oh, sorry, I was on mute. Sorry, just to put up my final slide. Is there a final slide? Well, no, just say thank you very much for everyone who attended, and thank you, Daniel, for the support. Anastasia, big thanks for the demo. And thank you also, Luca, for the extra time that you gave me and for setting up the quiz in a very short space of time as well. That was really great. So I'll not keep any more of your time because you need to go to your next presentation. So thanks a lot, everyone, and please, you can contact me or the Stmx SWG for any content-related questions, suggestions. Please feel free. Okay, thanks a lot. Bye.
okay, everyone, thank you, David. We'll take a very short technical break just to set things up for the next presentation on Sdmx REST API. So we'll start again on the hour. So at 6 o'clock if you're in Europe, at noon if you're on the eastern seaboard of the US, and at 11 if you are in Mexico. So in about 3 minutes, we'll start. Thank you. Hey, everyone. So I hope you had a nice short break. Welcome to the second presentation of today's session, which is going to talk about how you can access, retrieve Sdmx structures and Sdmx data using the Sdmx REST API, and how you can visualize or analyze data retrieved via the Sdmx REST API. During the session, before we start, I would like to once again remind you that in case you have questions, you can type them in the Q&A box, and we'll get to them when possible. And I am accompanied here and supported by Daniel Ciurani from the ECB, who will be answering some of your questions as they come, and also highlighting the ones that I am supposed to answer. What we're going to talk about today in this presentation, I'm going to show you how you can retrieve Sdmx structures and Sdmx data using the Sdmx REST API. I'm going to do a little demo of that as well. And then I'm going to talk a bit about the different tools and connectors that you can use to analyze and then visualize data that comes from an Sdmx REST API. Let's get to it. So one of the things that we mentioned in the past 2 days, and that in my personal opinion is one of the best things about the Sdmx standard, is that besides giving a standard way of modeling data and of representing data and of exchanging data, Sdmx defines a common API and a common set of web services that you can use to retrieve Sdmx objects and to retrieve Sdmx data. This means that there is this standard SOAP and REST interface for Sdmx. Any Sdmx compliant web service will allow you to retrieve Sdmx objects and Sdmx data using the same web service or REST API syntax, which is quite great, especially when you need to retrieve data from multiple sources that all follow the Sdmx standard. So how does this actually work? How can you actually retrieve data, Sdmx object and Sdmx data from an Sdmx REST API? First of all, I want to clarify, the Sdmx standard supports both SOAP web services and REST APIs. I'm going to focus on this presentation on the REST API for 2 reasons. First of all, it's simpler, and it's also easier to do a quick demo using the Sdmx REST API. And second of all, when it comes to Sdmx 3.0, I hope I'm not revealing anything or spoiling any surprises for the global conference, but as part of Sdmx 3.0, the Sdmx SOAP services would be phased out with a much bigger emphasis on the support of the REST API, which then means that it's better to focus on that. And with the REST API, you can retrieve both objects and data. And I'm going to show you the syntax for objects and then the syntax for data, because the syntax is a bit different, and then we'll go to a little demo. So how do we retrieve Sdmx objects? And when I talk about objects here, I talk about all the different artifacts that we talked about over the past few days and that my colleague Abdullah introduced in the first day of the training. Data structures, data flows, metadata structures, code lists, concept schemes. All of these are objects that you can retrieve with an Sdmx API. And for any object, whatever it is, the syntax is always the same. It has 6 main elements, which are the following. First, you have the root URL, which is the location of the REST service. This is the root URL is the only element which is dependent on each organization. Each organization has its own web service, its own service location, and therefore the root URL will depend on whether you're trying to retrieve objects from Eurostat's web service, or from DCBs, or from the MS, or from the global registry, or from wherever. That will be the element that will depend on the implementation. But after the root URL, which determines the location of the REST service you're trying to query, everything else is standardized. So after the root URL, you have to put the object type, the type of object you're trying to retrieve. As I mentioned before, this can be a data flow, it can be a data structure, it can be a concept scheme, it can be a code list. It can be other things as well, but those I think are the main ones. Then you need to, after specifying the type of object, you need to give the ID of the object. And if you remember what Abdullah introduced or mentioned at the beginning of the course, each maintainable Sdmx artifact is identified by 3 elements: by the maintenance agency, by the ID of the object requested, and the version. These are the 3 elements that uniquely identify an Sdmx object. And since these are the elements that uniquely identify an object, it's quite normal that in the REST API, when you want to retrieve an object, you have to provide the 3 of them. You have to provide the agency ID, you have to provide the ID of the object, you have to provide the version. And then after you have provided all of this information, you said what kind of object you want and the ID of the object and where you want to retrieve it from. There are some additional parameters that you can provide, which are optional. And these parameters are very useful to specify the amount of information you want to retrieve. So for example, if I'm trying to retrieve a data structure, a DSD, I may want to retrieve only the DSD itself, or I may want to retrieve all the elements that are linked to that DSD. I may want to retrieve the concept scheme and the code list as well, not just the DSD itself, because if you remember, the DSD is linked to concept schemes, it's linked to code lists. And the level of detail, the level of information that I want to retrieve with an object can be parameterized in the parameters, and most notably the detail and references parameters, which are optional at the end of the REST query. So that's pretty much how it works for an Sdmx object. Root URL, the type of object you want, the ID of the object by specifying the agency, the object ID, and the version, because that's what uniquely identifies an object in Stmx, and some optional parameters at the end to control the level of detail or information that you actually retrieve. Now, let's see a couple of examples. I'm not going to show you this over the course of a demo, but if you want to, let's see a couple of example of actual queries that we can make to retrieve objects. So here I'm taking the example of data on unemployment by sex and age, which is available on Eurostat's website for all EU countries, and which is available with, which has data flow ID UNE_RT_M. And the query for retrieving this data flow is the root URL of our REST service, which this is Eurostat dependent. It depends on the source that you're trying to query. The type of object that I'm retrieving, data flow. The agency ID, in this case, it's a Eurostat web service, and all of our objects are maintained by us, so it's Stat, Eurostat. The ID of the data flow, UNE_RT_M, and then the version. For the version, if you're unsure about the version number that you want to retrieve, you can just put the keyword latest, and an Sdmx compliant web service will give you the latest version of the data flow that is available in that data source. So that's a very easy keyword to be able to use in case you're unsure of the version that you want. This data flow has a corresponding DSD. I'm going to show you later how you can know what is the ID of the DSD. But for the DSD as well, you need to retrieve the you need to formulate the syntax as is shown on the screen. You have the root URL, then you have the type of object, data structure, the maintenance agency, the ID of the DSD, and once again, the version. If you're not sure of the version, just put latest. One thing I wanted to mention, which is very important, the basic syntax of Sdmx Web Services is the same. Now, what you should know is that in practice, not all Sdmx Web Services support necessarily all the operations that are foreseen or allowed by the standard. So, for example, in our web service for dissemination in Eurostat, for object requests, we do not support the references and detailed parameters. Other web services from other organizations may support them, or other web services for other organizations may support them only partially. So the basic query for all web services will be the same for any Sdmx compliant web service, but each web service may have slight differences in implementation, in their implementation on to what extent they support additional optional parameters. So that's one thing to keep into account and to keep in mind when you're actually trying to retrieve objects. So that's pretty much the syntax for objects. Once again, root URL, type of object, the agency, the ID of the object, the version, and some optional parameters. And it's the same for any Sdmx compliant web service to retrieve objects. Now, objects are one thing, and they're important, obviously. If you want to know the structure of your data, you need to know you need to be able to retrieve the objects. But what most users care about is not the object, it's the actual data itself. Not so much the structure of the data, but the actual data that they want to retrieve. And the query for data is follows a slightly different syntax than the one for objects, which comprises 5 elements. Actually, 4 main elements. The first one is once again the root URL, which is location of the REST API. It's, as mentioned before, it depends on the specific source, the specific web service that you're trying to query. That will really be dependent on what you're trying to do. Then you have, after the URL, you put data to specify that you want to query a data element and not an object. And then you have 3 elements. The reference to the data flow that you want to query, so the ID of the data flow that you want to query. The key of what you want to query. So when I mention the key, here we need to take into account the structure of the data. So as you know, by now, each Sdmx dataset is described by a DSD that has a set of dimensions, and the dimensions together form the key. And in order to specify what subset of the data I want, I need to specify the key that I want. I could want the whole data set, so actually not specify any specific key elements, or I may want to retrieve some specific key elements. And I'm going to show you a bit later the syntax of the key, but here the relative position of the dimensions in the DSD plays a very important role. As Abdullah mentioned before, at some point during the previous presentation by David, Abdullah intervened and mentioned that the position is very important. Indeed, it's very important for this. Because the position of the element of the dimensions in the DSD determines how you write your key syntax. But I'm going to show you this in the next slide and in the demo. So don't worry too much about it now. Just know that you can put the key, or actually you need to put the key to specify what subset of the data you want. And then once again here you have some parameters. Some optional parameters which allow you to specify once again what kind of subset of the data you want. And here there is a number of parameters that are available, I think 6 or 7 overall, if I'm not mistaken. And once again, here for the parameters, each implementation of an Sdmx REST API for data may support only some or all of them. That depends a bit. But one thing that is very important and that I really want to emphasize here is that if you want to specify a time period for which you want to retrieve the data. So let's say you want to say, I want to retrieve the data for year 2018, or I want to retrieve the data from year 2016 to year 2020. This is specified in the parameters. It is not specified in the key. The time period, as Abdullah explained in the first session of this training series, the time period plays a special role in Sdmx. And therefore, when you want to specify in the query the time period that you're interested in, you do not specify it in the key. You specify it in the parameters by using the start period and end period parameters. And I'm going to show you an example of this in the next slide, and also in the demo. So once again, for data, I need to specify the root URL. That's normal. And then I need to specify what data flow I'm interested in, the key or keys that I want to retrieve, and I can then specify also some additional optional parameters to further refine my query. Let's see an actual example, once again, with some Eurostat. An example from Eurostat from the same table that I showed before, and I'm actually going to use the same table for the demo, which is the monthly unemployment rate. And I want to retrieve the monthly unemployment rate for Austria from 2010 to 2013. So I need to fill in the elements. The root URL is the root URL from our web service. Different Sdmx data sources will have different root URLs. The flow reference is the data flow ID I showed before. So in this case, it was UNE_RT_N. I'm interested in that data described by that data flow or modeled by that data flow, and I'm just going to put that reference. And then I need to specify the key. And here comes the tricky part. Because you need to know how many dimensions are in the key, and you need to know to what the order of the dimensions. So in this case, I'm interested in unemployment data for Austria. And you see that I put the code for Austria here at the end. It's in the 2, 3, 4, 5, 6, in the 6th position. And overall, I have 5 dots, which means I have 6 dimensions overall, because each dimension is separated by a dot. By the way, just if nothing is indicated for a dimension position, it means you're not filtering on anything. You're trying to get all the data available. You're not trying to specify any subset for that dimension. So in order to build this key, I could not have done it without looking at the DSD. I needed to know that there were 6 dimensions, and that therefore I needed to foresee 6 places for dimensions. And I needed to know that the code for Austria was 80, and that the reference area dimension was the last one, was in the 6th position. And then I could probably create my key. What this means is that to really create a good query, you need to look at the DSD. We need to look at how many dimensions there are. We need to look at the order of the dimensions, and you need to look at the specific codes that are associated to each dimension. Without the DSD, you cannot really formulate a relevant or correct query for data. And then, as mentioned, I'm interested in a specific time period from 2015 to 2017. This is not specified in the key, it's specified in the parameters. So here I put the start period and the end period, and this specifies the time period that I am interested in. And all of this together, if I put all the elements together, I will have a key that does what I wanted to do, which is retrieve the data from Austria from 2015 to 2017. So just to emphasize again, if I want to build a data query, and I want to build a data query for a specific subset of data, I need to know the order of the dimensions. I need to know how many dimensions there are. I need to know the order of the dimensions. I need to know how these dimensions are coded. How do I know all this? I need to look at the DSD. There's no other way. So I need to be able to look at the DSD before, and then I can formulate my query correctly. There is a way out of this. If you really don't know about the DSD, or it's not available, or you don't know what to do, well, you can just instead, you can just basically not specify any subset, and you can just use, instead of the different dots with the codes indicating the specific subset that you're interested in, you can just use all, the special keyword all for the key element here. But that means that you will retrieve the whole data set, which in some cases may be very difficult if you're dealing with very large data. So if you really don't know what the DSD is, or you don't want to look at it, and the data set is small enough, you can just decide to put all in place of the key parameter, and then you don't need to worry about the dimensions, you don't need to worry about the codes, you don't need to worry about the order, but you will need to, you may get a lot of data if you're not.
Luca, sorry to interrupt you. Can you go back to the slide just to clarify? There were questions, but I wanted to put it for everybody to listen. First of all, on the key, the dots, the formatting is a bit weird here on the dots, but there's no space between the dots. So there are 5 dots in a row. Yes. So I think that's a formatting issue, but if you put a space between the dots, then there would be an error of the web service. So you should not put space. What is between the dots is only a list of allowed codes. So in that case, it's 80. You can look at the web service specification of Sdmx. You can also search for multiple codes. So for instance, if you would want Austria and Belgium, you would put 80 plus BE. You can do that too. And for each dot, you would need to put valid codes from the code list of that specific dimension. And you would need to know the position of the dimension, as Lucas mentioned. So there's no space between.
Yeah, indeed. Thank you for pointing that out. This is just there's no space between the 4th and the 5th dot. I think I just made it a bigger font by mistake, and it looks like there's a space.
It looks. But and the second one, there's a typo in the slide. So obviously, if you want the unemployment rate between 2010 and 2013, you need to put in the URL 2010 and 2013 and not 2015 and 17. There's no magic math happening. That's just a typo. So that's just an example, but you would need to put the periods you want to have. And if you leave the periods, you get the complete time series.
Anyway, we're going to do a demo, and I hope that during the demo, some of these potential doubts will be clarified as well. Going back a bit to the, and thank you, Daniel, for pointing this out. Indeed, it was misleading. So another caveat I wanted to point out, except the key and how you can decide to retrieve the whole data set without specifying a key, is the format. I did not talk at all so far about the format of the response. And you should know by now, after these 3 days, that you can have Sdmx data in different formats. You can have, I don't know, Sdmx JSON. You can have Sdmx CSV. You can have Sdmx ML, and Sdmx ML itself has several different flavors. There is Sdmx ML compact. There is Sdmx ML structure specific. There is Sdmx ML generic. So, okay, so how do I specify the format? I'm just doing a query. What is the format I'm getting? So what you should know is that the default format for the response of a REST API, according to the Sdmx standard, is the Sdmx ML generic format. In general, if the API is built according to the standard, when you make a query and you don't specify any format anywhere, you will get back Sdmx generic, which is not the most efficient format to pack data. If you want to retrieve another kind of format, say you want Sdmx compact or you want Sdmx JSON or something else, then you need to insert this in the accept element of the HTTP query header. And that's a bit more difficult to do in the sense that you need to have a proper REST client to specify the elements in the header. It's a bit more difficult to do with a simple browser, as we're going to do for the demo. But you can decide which format you want returned, but you need to do that by modifying the accept element of the HTTP query. And otherwise, if you don't specify it, you will get back, according to the standard, Sdmx generic format. So very important point about the formats. You can choose them, but there is a specific way to do it. Now, before I go to the demo, which hopefully will clarify a bit how all of this works, I wanted to point you to some very, very nice material and documentation that is available here. The whole Sdmx REST API is very well documented on GitHub. So I'm just going to go on the GitHub site now. I'm going to leave the presentation aside for a second and just open GitHub if I manage. Okay, so this is the GitHub repository where all the documentation of the API is available, and of the REST API. And as part of this documentation, you have two excellent resources. One is a very nice tutorial, about how to use the API with some very nice tips and tricks that you can use. And the tutorial goes in much more detail than I'm going to go in this presentation. In this presentation, I'm only covering the data queries, so this part of the tutorial, and the schema queries, so this part of the tutorial. But you have other features of the API which are covered in detail by the tutorial. So I really encourage you, if you want to know more, if you're stuck at some point and you want to understand why, some tips and tricks, this is an excellent resource. And then, besides the tutorial, there is another excellent resource, which is the Sdmx REST API cheat sheet, which I'm just going to show you very quickly. It is a PDF document which, in 2 pages, summarizes everything you need to know about the Sdmx REST API. There is a section. The first section here explains to you how you can create a query for an object, and you can see that it follows the same structure that I showed before. And he explains to you also what are the different acceptable values for the different elements. And for data queries as well, you have a very good documentation of how you can build your query, as I explained before, and a documentation of all the different parameters that exist. Once again, not all RESTful Sdmx REST APIs support all of these parameters, but these are the parameters that are accepted by the standard. And then in the second page, you have some very nice information on more technical matters, the different response codes you can get, how to format dates properly, which is important also for the data queries. And what I mentioned here, how you can specify that you want data returned in a specific format. It gives you here the syntax that you need to use in the accept element of the HTTP header to specify the format that you want. So I don't know, Daniel, who made this exactly, but it's.
I don't know either, to be honest.
But it's an excellent resource, and even myself, I use Sdmx APIs quite often. I often do it with the cheat sheet by my side, just in case I forget something or I need a confirmation of something. It's a very useful resource. So if you want to use it, be sure to download it and check it out, and it will probably solve most of your problems without need for further intervention. So after having talked a bit about how this is supposed to work in theory and showing you a bit the different resources that you can leverage to make your queries, to build your queries, let's go to an actual use case, and we're going to do a quick demo. I'm going to try to retrieve some data from the Eurostat website and from Eurostat's Sdmx REST API on demography. And I'm going to try to retrieve some data for a specific year, so for year 2016. And actually, I'm going to try to retrieve demographic data specifically for Portuguese women. For whatever reason, I'm very interested to know how many Portuguese women there are in Europe. So I'm going to show you how to do that step by step so you can build your query. And yeah, let's go. And once again, if you missed something during the demo, you can ask some questions in the Q&A. This session is recorded, so you'll be able to look at it in the future as well. The first thing I'm going to do, just to give you a flavor of the kind of data that we're trying to retrieve, I'm going to go on the Eurostat website and I'm going to show you the data set that we're interested in, just so you know what to expect. Okay, so this is a data set. It's a data set that has data flow ID demo pgen, which is demography data on population on the 1st of January. And I can just open the data set and you will see a bit what it's about. It's something quite simple. It's data on population for every year, for every country, and subdivided by age. So there's different age classes available, right? Different years of age or different classes, and by sex. So I can have the total, males or females. This is pretty much what the data set is. Population data by country, data set, sex, and age class. And the ID of the data flow is demo_pgen. Now, my objective here is to retrieve data for Portuguese women in 2016. Don't ask me why. And I need to therefore build a query. For this query, I'm not interested in the whole data set. I'm interested in a specific subset. And so I will need to know how to build an appropriate key for this query. And how do I know that? How can I know how to build a query? I need the DSD. There's no other way. Good. I need to look at the DSD, look at the dimensions, look at the codes that are being used, and look at the order to build the key. How do I get the DSD? Because here, I don't have any indication about what the DSD is. The only thing I have is the data flow ID. Well, the data flow contains information about the DSD. So the procedure I'm going to adopt, and obviously, if you're doing this on a regular basis, you can automate all of these steps, kind of, but I'm just going to show you a bit the way of thinking about how to approach the problem of how to retrieve a specific subset of data. I know the data flow. I'm going to retrieve the data flow, object and therefore know what the DSD for this data set is. Then I'm going to retrieve the DSD object. And based on the information of the DSD, I'm going to know how many dimensions there are, the order of the dimensions, the codes to be used for the dimensions. I'm going to be able to build a data query for the subset I'm interested in. That's a basic approach. Let's start. First step, I need to retrieve the data flow. So this is an object. I'm going to just zoom in, if possible, on the not sure I can zoom in on the search bar. Okay. Yeah, the zoom only works below. Anyway, oops, sorry. So, first thing to do, I want to retrieve the data flow. The data flow is an object. So, for the object, I need to specify the root URL, which in this case is the root URL, the location of the Eurostat's REST API. This you cannot know. You need your data source owner to tell you. Then I need to put the object type, the maintenance agency, the ID of the data flow, and the version. So I'm looking for a data flow. Object type, data flow. That was quite easy. And the maintenance agency. Okay, this I know. It's a Eurostat web service, so it's going to be Eurostat. The ID of the data flow. Well, I saw it before. It was this demo_tgen. And then the version. I don't really know the version, but I don't care. I just want the latest version of this data flow available. So I'm just going to put the keyword latest. There we go. And quite quickly, I have my response, which is a nice Sdmx ML object with the data flow. Now you may ask, okay, Luca, thank you, that's nice, but you're cheating a bit. What if I don't know the data flow ID? What can I do then? Well, if you just want to query a bit and know what data flows are available for a given data source, because you're not sure which one you want, or you just want to see what is available, you can wildcard some of these elements, right? So if I want to know what are all the data flows available maintained by Eurostat in this available in this web service, instead of putting a specific data flow ID, I can just put all, right? And also the versions, I can just put all as a keyword. And this will give me a list of all the different data flows that are available, and then I can explore that list and see exactly which is the data flow that that I could be interested in. But in this specific case, I knew the data flows in advance, and so I could just retrieve the one I wanted. But in case you're exploring, you can use the all keyword to see what is actually in your web service, in the web service you're querying. I mean, usually most web services anyway have a documentation that gives you the list without forcing you to do a query, but this is how you would do it with a query. Okay, so I have my data flow. It has the right name that I expect, population on 1st of January by age and sex. So, okay, it's the data I want. The data flow doesn't have much information, but it has a key information element, which is the DSD. The data flow tells me what is the DSD used by that data flow, used for that data. And it gives me the reference to the DSD. It tells me this is the ID, this is the version, this is the agency. That's all I need. With this information, I know what is the DSD for this data flow, and I can retrieve the DSD. Let's do it. So I'm just going to keep this a bit. I'm going to keep this here just so I have it under my eyes. Actually, I'm going to make this a bit smaller. Put it here. There we go. We have both things available. So I want to retrieve the DSD. Once again, the DSD is an object. So I need to do, again, an object query. I have my root URL, which is the same as before. Then I need to put the type of object. What is the type of object here? It's a data structure. Question you may ask now, how do I know that I need to put data structure and not DSD? How do I know the right keyword? That's where the cheat sheet come in. You look at your cheat sheet, which I should still have available here somewhere. In the cheat sheet, you will see the right keywords to be used for all objects, and you see that for DSD, it's data structure. That's how you know. You cheat with the cheat sheet. Very easy. Then, what is the Dsd I'm interested in? Well, I need to put the maintenance agency, the ID, and the version. Okay, I have all the information here from my data frame. So maintenance agency, Stat, the agency ID, you have it here. The name of the DSD is Dsd Demo Gen. The name of the version is 1.0. I could put latest here as well, but doesn't really matter. Okay, and once again, it seems it was successful. I have retrieved a very nice DSD. The DSD here contains the data structure, but also all the concept schemes and all the code lists that are tied to this data structure. What I really care about here is, first of all, the number of dimensions, because once again, I'm doing all of this because I want to retrieve the data for Portuguese women in 2016. That's my end goal. And in order to formulate this query correctly, I need to know how many dimensions there are and the order of the dimensions. So I'm just going to look at the dimensions available. I have a frequency dimension, a unit dimension, an age dimension, a sex dimension, a geo dimension, and then the time period. The attributes, I don't care for the for our purposes now, for the query. They're not part of the key. I only care about the dimensions. And so I see that I have 1, 2, 3, 4, 5 dimensions plus the time dimension. Great. So that already allows me to start doing something with my query, for my data query. By the way, just to emphasize something that Abdullah also mentioned yesterday, I'm looking here at the XML. I think it's useful for you to know more or less what the XML objects look like. In many cases, in most cases, the DSDs will be stored in a registry somewhere. And if you know which data flow you're looking for, if you know which DSD you're looking for, you should be able to just go to the registry and retrieve this information in a more user-friendly fashion. But I want to show you how it works with the REST API and what the outputs of the REST API look like. So now I want to start formulating my data.
Yeah, look, just to mention at that point, because you mentioned the registry. Also, if you look at the global registry, for instance, it has a query builder where you can actually create this URL for a DSD and then copy it and then put it in your tools or whatever. So to browse the registry to actually discover what you want is quite easy and straightforward in a graphical way as well. So if you exactly. So if you look here at the web service, you can query, you can have data structure or schema queries, and you can use the interface to build your query here, and it will follow exactly the same structure that Luca has shown. But it's also good, I think, to know how it's built from the XML. So if you have the XML artifacts, you know how to build the queries, but the registries can help you there too.
Exactly. So the global registry does offer this guided interface to build in a REST query. It is based, or it works based on what is in the global registry, right? If you're looking to build a query based on something that is in another registry, or in another data source, it will not have the right data flow ID, it will not have the right data flow versions available because it's based on what is in the available in the global registry. But yes, it's a very nice resource to better understand how the queries are built as well. So where am I? So I want to start building my data query. And once again, I take the root URL, I add data to say that I'm interested in data this time and not just about objects. And I need to start putting the other information. I need to put the reference of the data flow, which is demo Dsd, because I'm interested for the data set described by this data flow. Perfect. And then I need to start building my key. So the first thing I need to know is that, okay, I'm going to have 5 dimensions. So I need to foresee spaces for 5 dimensions. The frequency dimension, I don't care about. I don't need to filter. I don't want to filter on it. So I leave it blank. I don't put anything, and I put a dot. This means that I'm not looking for any specific code in the frequency dimension. The following dimension is unit. Do I care about units? No, I'm not interested in a specific unit. So once again, I don't put anything. I don't put a space. I just put another dot. And here I'm saying that I'm not filtering unit. Then I have age. As I mentioned, I'm interested in Portuguese women of any age. I'm not picky from that point of view. So I'm just going to not filter on age. So I don't put anything after the in the third position, in the 2-dimensional position, and I just add another dot. Here comes sex. Now, sex, I'm interested in. I want to have Portuguese women, as I mentioned. So I need to query for women. How do I know which code I need to query for women? Well, in the DSD, I know that the sex concept is described by the sex code list. I have it here. I mean, to be honest, it's maybe the code is F for females. It was quite straightforward, but I have in the DSD the code I need to use. So it's like, okay, well, if I want women, I'm going to need to put an F. And then after the F, once again, I put the dot. And then, finally, I put the geo, Portugal. The code for Portugal, I could check it in the DSD. I can tell you it's PT. There you go. And I have built my nice query. What about the time period? Well, as I told you, the time period, it's not specified in the key. It's specified in the parameters. So I've built my key. I've specified in my key what is the subset that I want. Now I can put the additional parameters. I said at the beginning I'm interested in the data for 2016. So I'm just going to use the start period parameter and the end period parameter to focus on 2016. I'm going to say I want to start 2016 and end in 2016. So I only get the 2016 data. Parameters are always introduced by question mark and are separated by an ampersand sign. And this should be it. This should be a well-formed query for Portuguese women in 2016. Is it going to work? I'm not sure. There's always some suspense when we do this.
Luca, there's a question why the time period is treated differently in the REST query.
So, I mean, I can give my answer. I'm not sure if it's really the correct one. You can complement Danny. Time period is a specific dimension which is not coded usually in Sdmx. It's Sdmx has a syntax for the time period, for how you have to express years, quarters, month, etc. And being able to have it in the parameters allows you to specify a start and an end, for example, like I'm doing now. And you don't need to know actually the exact format of the time period. If the data was in quarters or in months, I would get all the months for 2016 and all the quarters for 2016. And if it's in years, I only get 2016. If it's in weeks, I will get all the weeks of 2016. So the reference period in Sdmx is coded according to a very to a strict format. And by doing it this way, I don't need to indicate a specific code, I can just indicate a length, and then it will be the Sdmx REST API that understands, okay, well, I know what the length that they asked me is, I know what are all the time periods that fall within that length. So to be honest, historically, I cannot really say if that was the main reason, but from the practical perspective, I usually don't want to specify the time period as a code. You want to specify it as a length and not really care about the periodicity of it. And this allows you to do it. If I had the data on population in months, I would use, I want all the months, I would use exactly the same query. I wouldn't need to specify each month in the key, which would be quite annoying. So once again, I'm not sure if that's the reason that it was done this way, but that's definitely the main advantage, I would say. I'm not sure, Daniel, if you want to complement with your own experience. Maybe you actually know the reason.
No, I would say I actually also don't know the reason, but I agree with you. It's very practical that it's done that way.
Yeah. So let's see if I got my data, because it took a while, but I got to read the answer. Yeah, and this is some nice Sdmx generic data with information on Portuguese women for each age group available. So I have the total age, I have unknown age, I have 1 year old, etc. with the observation value here in Sdmx generic. Why is Sdmx generic? Because I didn't specify the format. That's basically it. One more small point that Daniel highlighted before. What if I want, and which is specified also in the cheat sheet, what if I'm interested in both Portuguese and Spanish women, and I want to enlarge my search for a potential mate? Well, I can do that by just specifying multiple codes in one dimension by just adding a plus. So if I want Spain plus Portugal, there you go, PT plus yes, you'll get a data set which has double the data because we also have the Spanish data, but it will work. So that's an easy way to, a quick tip that I wanted to show you. Okay, that's pretty much it for the demo. I hope you were able to follow, and the main point for me to carry across was really the thought process of how you go about building a data query. You have to know the data flow, you have to know the DSD, and after you know that, build a query according to the specification of the REST API. Any specific questions I should answer now, Daniel, or I can move on?
No, the question was when the session will finish. That's the current one in the Q&A.
Sorry? I didn't catch that, Daniel.
The current question that's open in the Q&A is when the session will finish, so how long it will still take?
It's foreseen to finish in about 10 minutes. So I need to wrap it up for our ENG hosts. So we saw how to retrieve data. And then I want to give you just a few pointers on how you can visualize and analyze Sdmx data. One thing that people always say when they first look at Sdmx, they look at an exercise that the one just gave you. They look at the Sdmx XML file that they get from a REST API, and they say, okay, that's very nice, but I cannot read this data. I mean, it's XML. There's all these tags. How am I supposed to do something with it? This is very annoying. And I want to convince you that it's not. No one expects you to actually do what I did, which is show you the XML and then read it or analyze it visually. There's many things you can do to actually visualize and analyze your Sdmx data. You can, in case you have the Sdmx data in some format, you can convert it to some other format that you like best with a converter. That's possible. We saw that yesterday. It works. It may not be the best solution. But I want to just point you to what I think is the two best ways of doing this. let's say you want to have a quick look at an SDMXML data file and understand a bit what's in there and treat it quickly. And you don't want to use a converter or any other tool. Well, to be honest, in most cases, just Excel works fine to open and do a quick analysis of the data. I'm going to show you how to do that in just a second. If you want to go deeper and not just open the file in Excel quickly, but you want to actually analyze it, do some proper analysis, do some proper visualization, then you can use one of the many analytical libraries, connector libraries that exist for Sdmx REST APIs to your favorite analytical software, or Python, Power BI, whatever you want. You have connectors available. You can plug them to connect your REST to an Sdmx REST API, and then you can do whatever you want with your data once it's in your favorite analytical software. So, yeah, this is just a quick trick. It's really nothing major, but it's something that people often miss, and it's really just a quick trick. I receive an SDMXML file. I don't want to mess around with the converter. I just want to understand more or less what's in it, but I cannot understand the XML. How do I view the data? In most cases, your file will be in an SDMXML compact or SDMX structure specific. You just need to open it with Excel, and you don't need any additional tools, any complicated things. Just if you open it with Excel, it will be enough to give you something quick. That's it. So I just want to show you how to do it. It will take really 3 seconds. And then hopefully in the future, I will not have questions by people asking, well, it's impossible for me to open or to look at the data that I'm in the Stmx. So let's look at it. I have here. Sorry.
Luca, there's a quite specific question in the chat now related to what you mentioned before on the frequency. I will read it out. So if the data set contains a mix of quarterly and annual data, does the time period dimension specify differently, or does it change the REST query? So if I understand the question correctly, and Vilas, you might correct me if I'm wrong, but it is if you have mixed frequency data sets, would you need to query differently with the REST URL?
If you only want to retrieve data, if you don't specify the frequency in the frequency dimension, then by just specifying the start and end period, it should return all the frequencies, all the data that falls into the start and end period. So let's say I have annual and monthly data, and I specify start 2016 and 2018. I would get all the monthly data and all the annual data that is available for between those dates. But if I want to focus on one frequency, well, then I just need to specify the frequency code in the frequency dimension. The frequency dimension is recommended to be in all Sdmx Dsds. It is usually the first dimension in most Dsds. So if you just want to retrieve the monthly data or the annual data because you have multi-frequency thing, you just put A or M in the query in the first position, usually the first position, and you're able to filter out only the frequency that you're interested in. If you don't do it, you'll get everything by just specifying start and end period. If you want to focus on one frequency, you can do that by specifying that in the key. I hope that answered the question. So I have Excel, very very common tool. I want to open an SDMXML file, and I don't want to start messing with plugins. I don't want to start messing with converters. I just want to see a bit what's in the file that I received. And I received a file, which is a file in SDMXML compact, actually the same file that I retrieved before, just in a compact format. Actually, structure specific thing. If you just try to open the file with Excel, it will ask you, how am I supposed to open it? As an XML table, you just click yes. Okay. You wait a second and you see, oh my God, all these columns, what am I supposed to do with all of this? You don't need to care. if you have an XML file in structure specific or compact, the data itself will be put in the last columns. Everything that precedes it will be kind of structural information that comes from the XML file. You can just remove it. And there you go. You have your data in a nice CSV format that you can analyze. You can do some pivot data, pivot tables on it if you just want to do a quick analysis. Let's say I want to once again find my Portuguese women for a given year by age. There you go. Portugal, where's Portugal? Time period 2016. And sorry, I need to put some here, otherwise it won't work. I'm just using basic Excel function, nothing else. There you go. I have a nice table. I can play around with it. I don't need to do much else. So once again, this is not, I'm not saying that this is how you should do data analysis. I'm just saying, if you ever receive an XML file and you don't know how an SDMX XML file, you don't really know how to handle it, you don't know how to use connectors, converters, you just want to take a quick look at the data. In most cases, you can just open Excel and that will be good enough, I think. So a very quick tip, not to be scared about Sdmx now. Okay, but this is really like entry-level stuff, right? I mean, usually most of you or most of your colleagues that work in data analysis, they don't just want to do a pivot table. They want to do something a bit better, a bit more sophisticated. And there, the good news, as I mentioned, is that there are plenty of libraries available in popular Statistical packages or Statistical software like R, like Python, like MATLAB, like SAS, like Stata, to retrieve packaging libraries that connect to an Sdmx REST API and that run the query and transform the result into the data structure, the native data structure of the language that you're using. So for example, for R, we will take the data structure and turn it into a data frame. And okay, actually, I don't want to go also in the interest of time too much detail here, but I just want to show you a quick overview of the different connectors that exist. You have at least 3 R packages that do a really good job to connecting with data sources. You have an excellent Python package that's the same. You have packages from MATLAB and SAS. You have one for Power BI. You have a couple of packages for Excel that kind of do the same thing that I showed you, just in a more sophisticated and less homemade manner, I would say, more professional. So definitely, if you're a frequent user, I would suggest to use the Excel plugins rather than what I showed you very quickly. But still, and all of information about all of these connectors, you can find it on sdmx.org in the tools section. I think we showed you this yesterday or another day. If you go on sdmx.org, you have the list of SDMX tools available, and among them, you will find also the different connectors. You have the Allostat Excel plugin, the Panda SDMX, the Read SDMX, R SDMX, different connectors for Statistical software produced by Banca Italia. Very, very good resource. And to be honest, that's about it. To finish this, I would just like to, maybe if I manage,
Luca, while you try to manage, I will just answer one more question from the chat while you are browsing.
please.
So the question from Vilas on the time period dimension. When we use the standard time period dimension, do you have to map your data file to the Stmx codes? So basically, the time dimension is not coded. It uses a time format, which is derived from the ISO period format. So you can also see in the documentation what it looks like. So basically, if you have annual data, it's only the year. in a 4-digit number. And if you have data that with another frequency, then you have specific way to express it. Like, for instance, monthly data, it would be the year and then dash and then M and then the number of the month. So for January, M01 until M12 for December. And in order to be compliant with the DSD, your data should return that format as well. So if internally in your database you have a different time format, then you need to create that before you connect it to the Sdmx web service. So your data, basically all the dimensions and attributes should respect the format that is specified. And in case of time, you would need to map it to this format. That is something that is done in the backend. So if you're a client of a web service, you will be ensured that the backend calculates it correctly. If you want to offer data to the world, then you would need to map your backend to the Stmx period data format, which is the ISO one actually. So it's not invented by Stmx, but you can also see this definition on the ISO website, and also in Stmx you see what it looks like. And to make the queries work, it needs to respect that format.
Thank you, Daniel, for taking that question. So in the meanwhile, I just want to show you this. It's an example, but I think it illustrates well the power that Sdmx REST APIs bring for data science or for data analysis, for anyone interested in analyzing data. What you're seeing here is a web application that was built using R, using the Shiny framework of R for web applications. I'm not sure if any of you are aficionados of R, but if you are, you probably know about this framework to produce data visualizations. And what this is doing is quite simple. The app is connected to 5 Sdmx web services from 5 different organizations: IMF, ECB, Eurostat, OECD, and UNSD. It's retrieving the data using the Sdmx REST API from each of them, using the same Sdmx Sdmx syntax that I showed you before. And it's trying to retrieve GDP data for a specific country. So you can select the country, and in the background, the application retrieves the data from the REST APIs and just displays it for you. And you can see here, for example, that for whatever reason, the UN has slightly different data for Denmark. Now, this application is very simple. It's not something that is something I want to dwell on, but it's just to show you. You have a standardized interface. You can connect with standardized connectors to those standardized interfaces. And if you know how to use the statistical software target to make visualization, you can quite quickly come up with something nice, federating different sources just by using the Sdmx REST API. And this is just to give you a flavor of the power, what you can do with statistical software and the advantage that you have of exposing your data or retrieving data from Sdmx data sources. That's basically it. Very conscious about timing, so I'll just summarize the key messages for this presentation. There's a standardized way to retrieve Sdmx data objects, Sdmx objects, and Sdmx data. It's a standardized way. It's defined by the standard. It gives you a common interface, whatever the Sdmx data source, and that is great. And it's fairly easy to use, as you saw. And if you're interested in analyzing and visualizing data, there are several options available, several connectors available, from very easy ones, easy options, just opening data in Excel, to really building R-based visualizations or Python-based visualization using Python libraries or R libraries. That's pretty much it. I don't know if there are any other questions. And yeah. I'm not sure, Daniel, any other question that came in at the end?
At the moment, there's nothing in the Q&A. So I hope I answered some questions by typing in the Q&A. So if there's something not clear, please let us know so that we can answer it or go a bit deeper. But otherwise, at the moment, there's nothing open in the Q&A.
Okay. So with that, if there are no further questions, I would like to thank Daniel for his great support in the Q&A. I would like to thank all of you for attending the presentation, especially those of you for whom it's late right now. I know it's late here as well. So thank you for bearing with us. And yeah, I would like to hand it back to our hosts at ENG to close the session. Tomorrow, you will have the final session of the training, which will be held in the English track by Alessio Cardaccino from ESTAT. And it will show you a deep dive of really, and step-by-step, how to implement a data dissemination architecture with Sdmx using a specific set of tools. And I think that's something that could be quite interesting. And for many of you, it could put into practice or give concreteness, let's say, to some of the elements and some of the things you saw in the slides from Monday, yesterday, and today. Thank you, everyone.
There's a question now on how can we access the sessions. I think they're being recorded. Does any of the other hosts maybe know if the recording will be made available and where?
The recordings will be made available, as well as all the presentations on the conference website, together with all the conference presentations. So once the conference presentations are made available, the training presentation will be made available as well. For the recordings, I must say, it may take a bit longer just for them to be processed. This we need to check, but everything will be made available. And your main focal point to retrieve the information will be the conference website. Okay. Leonardo, you wanted to say maybe a few final words?
No words. Only to thanks all of you for your participation and all your time. Thank you very much.
Thank you, everyone. See you tomorrow.